Howdy, everybody. How's everyone doing?
Good.
Everyone happy to be in Chicago? Yeah. All right. Well, somebody is. All right, cool. Well, I'm Galen. I'm an engineer on the log squad, and I'm going to get us started on this talk, which shows you how to get faster insights from your metrics, logs, traces, and profiles. I almost said next slide, sorry. All right, but before you guys have been through this a few times. It's 18,001 now. If you have any questions, you know what to do. So yeah, it feels good to be here. It's a beautiful city. It's lovely weather, for me at least, from Minneapolis. I hope you plan some extra time to explore the city, because there's a lot to see and do. So this map shows a couple of things to do in the area, but let's talk about what's really important. Pizza. So where do I find the best pizza in Chicago? So there's endless options, and if you're non-native like me, you've got two ways to find the best pizza in the city. Option A, find a friend, someone who knows what's up, ask them where to go for the best spot. In my case, my friend Michelangelo, who is a pizza expert, but is also a bit opinionated, as only a Chicagoan can be, pointed me to the right place. So I put it in Google Maps, and boom, I'm there, 10 minutes. Option B, you go full tourist. You use Google Maps, you search around, maybe you find the right thing. You filter through all the options until you narrow down something that finds what you're looking for. So the difference between these two methods is like the shift we're making in Grafana's user experience, and is what we're going to be talking about today. Option A, asking the expert, is kind of like our traditional query-based system. If you're an expert, it's precise and useful. But option B, exploring with filters, you don't need to be an expert or a query wizard. You can start with a broad search, like pizza, and refine your options as you go. And that's where our new Explore apps come in. They make exploring your data as easy as searching for the best pizza, guiding you step by step to the solution, no expert knowledge required. Introducing the Query List Drill Down Suite. So as we go through this talk today, we're going to highlight all the ways that we have improved the experience so that you're no longer required to be an expert in LogQL, PromQL, etc. And instead make logs, metrics, traces, and profiling data accessible and actionable for everyone across the board. So let's get a little hands-on. Metrics drill down. So it's almost Black Friday. You and your team are getting ready for the big day, hoping that your system can handle all the customers. Things seem to be going good, so you go to bed. But beep, 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 2 in the morning, you get pinged. Your customers are seeing slow response times, web pages are timing out, your team is freaking out. So you jump into Grafana to hunt for some indication of what's going on. In general, you can narrow things down, but it takes time and understanding of the relations between your services, which is pretty hard at 2 in the morning. You know that there's slow response times, so you look for a metric that could be related to HTTP requests. You query it. You don't find the problem, so you find another metric. And you repeat this cycle until you finally find something that shows a spike, a gap, or some anomaly that indicates what's going on. But there might be other problems, like CPU usage or memory. So you have to continue this process over and over again until you finally have an idea of which service is misbehaving. And let's not even talk about how many hours it took you and your team Googling errors, trying to figure out how PromQL works in the first place. So now, with metrics drill down, you're able to quickly visualize telemetry from a Prometheus data source without writing any queries. You can dig into each metric, effortlessly click on metrics and related services, and organize metrics by namespace. Now it's much quicker for you and your team to perform an investigation, leading to faster time to first insight, or in the case that alert fired in the middle of the night, MTBTB, mean time back to bed. So now we're going to be joined virtually by Catherine from the metrics squad to show you how this all works.
Functionality of Explore Metrics some more. So as you can see, when you land on Explore Metrics, there's a list of metric graphs here. You can hover into one of them to show the metric description as well as the type. You can also search and filter for metrics. For example, if you knew it was coming in from a Kubernetes, or if it was coming in from a container, you can filter by that. or you can search for metrics as well. So in this case, I know that my customers are seeing slow response times. I think this might be related to a request metric, so I would search that. And I know this has been happening in the last 12 hours, so I could filter for that as well. Now, I'm seeing that there is a spike showing on this metric here, so I'm gonna go into it. And I'm gonna go into this breakdown tab, which shows a list of all of the labels. And I'm thinking these might be related to a certain endpoint. So I would select this label to dig into this some more. And I can see that this similar spike is showing up for this health endpoint here. So I would add this to a filter. So now that I see this filter with the health endpoint, I want to see if there's any other metrics that would also be having similar spikes. So I can see that this is also showing up for these sum metrics as well. So I may want to select another metric to do a bit of investigation as well. And I may want to do other things like share this once I figure out if there is a problem. So for example, I may want to bookmark this, and I can bookmark this view to look at later. I may want to share this with my colleagues so I can copy this URL. Or I may want to even view this Explorer, for example, if I wanted to, let's say, play with the query some more, make it a bit more complex, or even add this to a dashboard. Going back into Explore Metrics, I can see that there's also a history here where I can go back and forth between certain steps. For example, if I wanted to go back into the filter applied step, or if I wanted to go back to a step where I looked at another metric.
All right, so thank you, Catherine. So now we know that there's a problem, and we found some associated metrics, which gave us some understanding when and how our infrastructure is impacted. But we really need to know what the problem is so we can fix it or pass our investigation on to somebody who can. And this is where logs drill down comes into play. The challenges of looking for logs is similar to looking for metrics in Grafana. If you can't find what you need, it can be easy to get stuck and frustrated. You might know containers are crashing or have high resource consumption, but you might not know where to start looking for the right information in your logs. And even if you do, narrowing down your search can be hard if you're unsure which fields or patterns to focus on. Logs drill down streamlines the process of identifying and diagnosing problems in our infrastructure, the what and how, as opposed to metrics, which will help us discover the when and the where. Finding the right logs allows you to filter and refine your understanding of the incident. And that's why we created Logs Drill Down. So we're going to do a live demo here. Back to our metrics investigation, we learned, a couple hours ago, we got paged, we found out that users were periodically unable to access the website. Something's going wrong. So we jump into Explore Logs. So right off the bat here, we're seeing periodic spikes in error and warning volume in our logs. So we're just going to take these two services. It's 2 in the morning. I'm kind of tired, but seems like the right thing to do. So now we can either, at this point, we can kind of see, oh, okay, there's a visual anomaly. We can drill in and just look at a selection, and then maybe just read through our log lines and try to figure out what's going on. But I'm saying, okay, I know we've got some reports of slow request times, so I'm going to jump into my fields on the log lines, and I'm going to say, just show me all of the logs that took longer than 150 milliseconds. And then from here, I'm going to say, all right, well, now let's take a look at our jobs on these services. Okay, everything, it seems correlated, but maybe not too much. Let's go ahead and look at our pods. All right, well, interesting that it's, again, a mild correlation, and it seems to be equally impacting all of the pods that we have duration for. But I know that for recent data like this, Loki is an in-memory data store of patterns, which will kind of analyze the bits between your logs that have changed, right? And they'll tokenize out the high cardinality bits that are different, the timestamps and your trace IDs, and give you this view where you can kind of see, all right, again, it's 2 in the morning. I'm just going to pick everything that's kind of got this sawtooth pattern that seems to be correlated with that 5-minute spike. And then we're going to jump back into our logs. Suddenly we have a much cleaner view of what's going on. Take a look at our logs. Right there at the top, query lock timeout. That seems interesting. Whole bunch of failed requests. All right, already, without really doing any work or writing any queries, we can probably make a pretty safe guess that there's some job that's getting run every 5 minutes, causing our database to lock up. And people are unable to access the APIs. Explains everything, why we got pinged. So then from here, I might be skipping ahead. You might want to debug further, and you might want to jump into the traces on these logs. But we'll come back to that in a second. Oh, I was hitting the wrong button. But also, can we go back to the slides? Thank you. As part of this launch, we will be announcing support for OpenTelemetry and metrics and logs drill down. So we know that many of our customers use OpenTelemetry to collect and instrument their data, and now you can view your OTel-compatible metrics and logs in metrics drill down and logs drill down. So as a recap, with metrics drill down and logs drill down, you're able to reduce time to first insight, reduce time to diagnose a problem, leading to significant time and cost savings for you and your team, and improve your mean time back to bed. Both of these are GA'd and available open source and on-prem and in cloud. Ryan.
All right. All right, thank you. Okay, so now we've talked a little bit about metrics, about logs. I'm going to quickly go through traces, spend a little bit more time on profiles, since I imagine for a lot of you that will be a little bit newer. But basically, with our traces drilled down, you saw a little bit of this when Jen spoke earlier. You kind of understand what's going wrong, and traces are going to help you understand exactly where that's happening and how to fix it. And so we're going to play a quick video here.
Let's talk about traces drill down. Just like with metrics and logs, there's no need to write queries anymore. The interface guides you visually, allowing you to explore the data, notice patterns, and navigate with ease. The interface offers 3 distinct views for displaying your data. The first one shows you the rate of incoming spans, and this is the default way to browse your tracing data. There is also errors view, which only shows spans with errors in them, and this helps you pinpoint issues within your applications. And last but not least is this duration view, which allows you to identify and address latency-related concerns. All right, now let's go to the comparison page. Comparison page helps you understand which attributes are contributing to latency the most. So what are we actually comparing? Let's look at this histogram. You can see that the top slow requests are highlighted in orange, and that is what we call selection. Everything else that is not selected on this histogram becomes the baseline. And so now for each attribute key and value, you can see the percentage of how many spans are present in the baseline versus the selection. And so for example, for span name, you can see that there's this /profile span name, and it appears in the selection a lot more than anything else. There's a little bit of /contacts and /avatar sprinkled in, and maybe we should look into these as well, but /profiles definitely appears to be the biggest offender. And so to continue this investigation, you can click on this Add to Filters button until you get to a page that looks like this. You can see that there's now no difference between baseline and selection anywhere, and that's how you know that you probably filtered enough and you're looking at the most important spans that are contributing to the latency. And so what do these spans and traces look like? For that, we can go to the root cause page, and it will show us this aggregated view of all the traces that match our filters. So this is not just one trace, this is an aggregation, and it shows the most important spans. So typically, this is a very good overview of what's going on. And if you want to go deeper, you can click on one of these buttons, and it will take you to the regular trace page where you can do deeper analysis and work with specific individual traces. Last thing I want to show is how the same concepts apply to the errors view. For example, if you go to the root cause page, it shows us this aggregated trace view, and it highlights all the spans with errors in them. So now we can very quickly see which spans are causing the errors without having to look at every single trace. Similarly, if we go to the comparison page, it works the same way as it does for latency, but your baseline is now all the spans that don't have errors in them, and your selection is all the spans that do have errors in them. And as you can imagine, this allows you to very quickly identify all the attributes that are contributing to errors. And so that's it for Traces Drill Down. Back to you, Dimitri.
All right. I'm obviously not Dimitri, but yes, back to me. Can we go back to the slides? So Jen talked about this a lot earlier. I mean, I think the biggest takeaway here is that we've really kind of transformed the way that you interact with your traces to make it much easier to, even if you are going from not knowing what's going on at all, you can kind of drill down into exactly what's happening, which is why we renamed it to this. And so, we've talked about metrics, logs, and traces. Now for my favorite signal, I'm a little biased. I didn't mention earlier, I'm one of the founders of Pyroscope, which is the database behind our profiling product. And so, yes, I'm very biased, but I do think that profiling has, a lot of utility for a lot of different companies, a lot of different use cases. And here at Grafana, we're seeing it to be one of the most popular ways that people are getting a lot more value from their data than they used to be. And so, the reason why that is because profiling helps you complete the story of why something went wrong and how to fix it. So a lot of times, let's say your metrics are telling you that there's a spike in CPU, or your logs are telling you that there's, an out of memory error. With any of these kinds of situations, that's great. But at some point, some engineer or somebody is going to have to go write some code somewhere or change some config in order to fix the problem. And what profiling does is it takes you down to the line of code that's causing the problem so that you can actually fix the problem and not just know that something's going wrong. And so whether that's metrics, logs, traces, K6, Kubernetes, IRM, whatever it is, profiling always gives you just one level deeper, kind of that last 20% that you need to actually resolve the issue. The other side of that is that, or the outcome of that is that you can either be both proactive or reactive with profiles. Typically, metrics, logs, and traces tend to have value when you're reacting to something, and profiling has value before something even goes wrong. And so we most often see that in the form of cutting costs, but we also see that in the form of either getting rid of latency proactively or reactively, and then obviously responding to incidents. So I'll talk about the proactive version first. How does it help you cut costs? Here's an example of just a theoretical world where, or maybe not theoretical, a very common situation where years ago costs tend to be less. As time goes on, your costs will continue to grow. A lot of bloat, things kind of work their way into your system slowly. And then one day you wake up and someone's like, hey, we need to get our costs down. Where do we go to address that problem? What profiling does is it basically breaks down all of these various components of your system to tell you, okay, here's where all of your costs are being attributed. And if you wanted to decrease costs, here are the areas that you can focus on. And it even goes one level deeper than this, obviously, in telling you, here are the lines of code that are actually causing these problems. It does this using a flame graph. For the sake of time, I'm not going to go through this, but basically think of these are giant pie charts that essentially tell you, and they're even nested pie charts that essentially tell you this is the line of code, and it calls this line of code, which calls this line of code. and it'll tell you basically the width is 100% of your CPU or 100% of your costs. And then as you go from top to bottom, it'll tell you which lines of code are making up that 100%. So yeah, so here's an example. This is actually a company I used to work for, the reason that we started Pyroscope. And basically, me and Dimitri, who you heard earlier, were working there, and we had a queue that was like constantly overflowing. We couldn't figure out, what the issue was. And basically, long story short, we enacted a hacky version of what now exists as Pyroscope. And it was able to kind of show us like, hey, you're spending a lot of your CPU on, it was a compression task. And basically, we were doing what we thought we should be doing and compressing something. But a change in the underlying API of the thing that we were compressing had gone from compressing images to compressing videos. And as you can imagine, that's much more expensive. And then thus, it was causing our queues to overflow. This is something we wouldn't have been able to see if we didn't have profiling. And it ended up actually saving us ultimately like 20% of our CPU, which is around the number that we see most commonly with what people are able to save using profiling. Next is responding to things as well. So we have a couple of examples here. Shopify, one of our biggest users of Pyroscope, they spoke at this conference several months back. And they use profiling both preparing and during the heat of Black Friday, which if you're not familiar with Shopify, is a really large day for them. Everybody's using their online stores to buy a lot of things. For them, 1 minute of downtime can mean up to $2.85 million in lost revenue. So every minute is extremely important, and understanding where their resource allocation is and making sure that they have the proper amount of resources allocated is the difference between them losing millions of dollars and not. Similarly, Uber, they also spoke at this conference a couple weeks back, and for them, they were using it in that more proactive use case. And so for them, they were able to find 10,000 CPU core reductions, saving more than $1 million in their infrastructure costs by using this profiling to understand what they were doing. And they actually were able to integrate a Gen AI integration in order to automatically then recommend fixes and PRs and be able to resolve that. We have some product coming out soon to be able to do some things like that, and I'll show what we have in the Gen AI space in just a second here. Actually, yeah, I'll do it right now. So for this demo, basically what we're going to show is like a sample rideshare company. We do this more just to show conceptually what's going on. But you can imagine this, like each one of these boxes, if you're using Kubernetes, would be a pod, or if you're using, whatever. If you're not, it would just be a process. And essentially what this is it's saying, okay, we have our clients who are generating load. It's going to either the east, north, or south region, which we add the region label. And then it's either going to a car, a bike, or a scooter that you're ordering, and that goes with the vehicle label. And the way Pyroscope works is every 15 seconds, it's going to essentially like buffer these profiles, send them off to the server, where they can then be analyzed. And if we can switch to the demo here, yes. And so this is what it'll look like at the top level once you get into the product. Obviously, this looks very similar to the other ones that you've seen. But the difference is here, you're going to be drilling down until you get to the code level. And so at the highest level, if I switch to rows here, we're looking at our data source. We're looking at CPU. This is across a bunch of different services. We're going to look at the rideshare Go service that I was just showing there. And so the next thing is, okay, so we can see the CPU here. Let's look at the various profile types and see if we want to see something other than CPU. So we can see CPU, we can see memory, we can see in-use objects, allocated objects. And so let's say there was like a memory leak or something. This would allow you to be able to drill down into whatever that was. In this case, we're going to take a look at CPU and those labels that I was showing just a moment ago. And so here we have all of our labels. So this top chart is showing you CPU just overall, like something that you would get from your metrics. But down here, you're seeing CPU broken down by the labels that I was showing before. So we can see our region label here. We can see our vehicle label here, which were the two ones that I showed you before. We can see it broken down by totals, by maximum CPU, by histograms. I think totals kind of shows really clearly what's going on in this particular example. Actually, let me make this a little bit bigger. Sorry about that. In this particular example, so here we can see that over this last 30 minutes, the north region has used 16 minutes of CPU time. The south and the east regions have used 3 minutes of CPU time, or almost 4. And so in this case, let's say there's an incident, and that's the reason, or let's say we don't know if it's an incident or not, but we want to understand, like, what is the difference between the north region and the south region that's representative of this CPU usage. So we would select this, and you can basically select one as your baseline. So I'm going to say, this is what we expect since we see this multiple times, and this is the comparison. This is what we're trying to understand, what the difference is between the two of these. When I hit the compare button, and it's usually a little easier to see. I'm like super zoomed in here. So, but yeah, hit the compare button. And so basically what you have here is on the left, you have one query, AP South for this time period. On the right, you have another query, EU North for this period. And basically the flame graph that we get down here is showing us that in AP South, we were only using 32% of CPU on this check drive availability function. But in EU North, we were using 78% of CPU. And so in an incident scenario, now this saves you from digging through all the wrong parts of the code to figure out what's wrong. It's going to highlight in red, oh, yesterday when things were normal, you were only using this much CPU here. Today you're using this much. Or if it's a memory leak, yesterday this much memory was being used, and today it's much more, whatever that is. And we don't have a ton of time to go through all the extra bells and whistles here. But we have this LLM integration as well that will basically allow you to not have to read this yourself if this isn't a visualization you're familiar with. And this will actually break it down for us and essentially conclude that the problem is our mutex lock function, which is using more CPU than it should be using. And last but not least, I don't know if you are authenticated on GitHub, but let's see, we'll give it a shot. If you click the function details button here, and let's see if you are. All right, we got function details. So with the function details, you can also basically add a GitHub integration. We don't store any of this code ourselves, but basically now you can go from this like performance insight to seeing what's causing these performance issues. And in this case, it's because we designed this demo to have an issue. But you can actually see here, the reason that there's an issue is because for a period of time, we're simply just iterating I randomly to cause CPU so that we can show you a nice looking flame graph. But in your case, this would show something much more interesting. And you would be able to basically click this optimize code button, which is going to tell you not just based off the performance profile, but the performance profile plus your code, what you should do to fix this problem. And it's probably going to tell us, yeah, we should sleep instead of just iterating I randomly for the time period. So yeah, we can go back to the slides. I think that's pretty much everything. There may be, yeah, so you've seen a lot of the Explore apps here. The drill down apps here. The biggest thing to take away is that we've really focused on making it as easy as possible in order to kind of start from not knowing what's going on, drill down into exactly the root cause of whatever issue it is, and you kind of have all these tools that you can be most efficient as efficient as you need to be to do that effectively. So that's all I have, and thank you